Hello, physical science student. Glad you're here. We're going to be doing our lecture for section 5-1. The topic today is atoms, bonding, and the periodic table. Our objectives today are to state what the periodic table tells you about atoms and properties of elements, and also to explain how the reactivity of elements is related to valence electrons in atoms. Our lecture exercises are on page 156. They're the section assessment questions. Also, you need to take learning notes, which is about a page of notes, including the section assessment questions. All right. I want to begin by telling you that you need to have your book, a pencil, a paper out, and ready to go. Today's lecture, I'm going to be reading to you from the textbook. Read along with me, and have a good time. Here we go. All right, here's our first section of the book, section 5-1. The title is Atoms, Bonding, and the Periodic Table. Right here, we got some key concepts that we're going to be dealing with. We're going to be dealing with how reactivity of elements is related to valence electrons in atoms. What does the periodic table tell you about atoms and the properties of elements? Our key terms are valence electrons, electron dot diagram, and chemical bond. These are vocab words. To do well on your quiz tomorrow, you should know your vocabulary words. All right, let's start reading. Why isn't the world made only of elements? How do the atoms of different elements combine to form compounds? The answer to these questions are related to the electrons and their energy levels. The roadmap to understanding how electrons determine the properties of elements is the periodic table. Valence electrons and bonding. So on your notes, you might write a little subsection that says valence electrons and bonding. Okay? You learned earlier about electrons and energy levels. An atom's valence electrons, vocab word, are those electrons that have the highest energy level and are held most loosely. The number of valence electrons in the atom of an element determines many properties of that element, including the ways in which the atom can bond with other atoms. To help you understand valence electrons a little bit better, I'm just going to draw a little atom right here. Here's the nucleus. We all know what that is. And I'm going to draw two little rings around it. In the first ring, I'm going to have two electrons right here and right here. And on the second ring, I'm going to have three electrons. 1, 2, 3. Now, the second ring represents the highest energy level. It also represents the electrons that are farthest away from the nucleus. That means that these are valence electrons. They are most loosely held, farthest away, and in the highest energy level. Valence electrons. And if you are extra smart, you should know what element this is based on its atomic number. Dun dun dun. Next page. Electron dot diagrams. Each element has a specific number of valence electrons, ranging from 1 to 8. Figure 2 shows one way to depict the number of valence electrons in an element. An electron dot diagram, vocab word, includes the symbol for the element surrounded by dots. Each dot stands for one valence electron. Here's figure 2 right here. See, hydrogen has one valence electron, carbon has 4, and oxygen has 6, it looks like. Yeah. Chemical bonds and stability. Atoms of most elements are more stable, less likely to react when they have 8 valence electrons. For example, atoms of neon, argon, krypton, and xenon all have 8 valence electrons and are very unreactive. Class, do you remember? Wait a minute, what? Oh yeah, those are noble gases. Anyway, these elements do not easily form compounds. Some small atoms, such as helium, are stable with just 2 valence electrons in their first and only energy level. Atoms usually react in a way that makes each atom more stable. One of the two things can happen. Either the number of valence electrons increases to 8, or 2 in the case of hydrogen, or the atom gives up loosely held valence electrons. Atoms that react in this way can become chemically combined, that is, bonded to other atoms. A chemical bond, vocab word, is the force of attraction that holds two atoms together as a result of the rearrangement of electrons. So chemical bond is the force that holds two atoms together because of a rearrangement of electrons. All right, let's keep reading. Chemical bonds and chemical reactions. When atoms bond, electrons may be transferred from one atom to another, or they may be shared between the atoms. In either case, the change results in a chemical reaction. That is, new substances form. Later in this chapter, you will learn which elements are likely to give up electrons and which are likely to share electrons. You will also learn how the periodic table of the elements can help you predict how atoms of different elements react. Key checkpoint. What information does an electron dot diagram tell you? Anyone know? Sounds like a good quiz question. Yeah, okay. Alrighty then. Let's keep reading. Let's go to page 151. How the periodic table works. Here is a sweet looking periodic table. I've also got one on my computer that looks like this. Check it out. Mine's in color. I'll be using this one, but you please use the one in the book. How does the periodic table work? Let's read together. Recall. Wait, this is a good place to stop. Put me on pause and write a few notes about what you learned about valence electrons, about electron dot diagrams, and yeah, when you're ready, write down how the periodic table works. It's another section of your notes, and continue on. Recall that the periodic table is organized by atomic number, the number of protons in the nucleus of an atom. The periodic table gives you information about the arrangement of electrons in atoms. If you know the number of valence electrons that atoms of different elements have, you have a clue to which elements combine and how. Relating periods and groups. Look at figure 3 and think about how atoms change from left to right across the periodic table, or row. Let's do that right now. Let's think about it. Check it out. Here's the periodic table. How do atoms change across the period? What do you see? If you say they change color, you're not quite right. Check it out. Number 1, number 2, 3, 4, 5, 6, 7. They increase by the atomic number by 1. Each one has one more proton than the last one. Okay, so far so good. Let's continue reading. As atomic number increases, the number of electrons also increases. A period ends when the highest energy level has 8 electrons. Valence electrons of atoms in the next period are of a higher energy level. This repeating pattern means that the elements within a group or column always have the same number of valence electrons. All right, let's check that out on our graph here. Check it out. Okay. So each period represents a different energy level. Period 1 with hydrogen and helium have the same energy level. They're all in the first energy level. Now, period 2, let me get my selecting tool. Period 2 is in another energy level. They're all in the same energy level. And look, we've got 1, 2, 3, 4, 5, 6, 7, 8. 8 in each period. Wow, that's the same as 8 valence electrons. So, what about sodium? Oh, looks like the same thing. Sodium all the way over to argon, another 8. What's happening here? Basically, as each period, every period, you get a new set of valence electrons. There are 8 valence electrons in each period. So, you can tell how many valence electrons each atom has by looking at what period they are in. Group 1 has 1. Group 2 has 2. You skip the middle. Group 13 has 3, 4, 5, 6, 7, and finally, the perfect number 8, the noble gases. So if I was to ask you how many valence electrons selenium has, you'd say, oh, that's easy. Look, it's 1, 2, 3, 4, 5, 6 valence electrons. Selenium has 6. Not too shabby. Let's keep on reading. Oh, I'm about to stop the video. There's another video for you to see. Check it out. That's part 2. Take a break, look at the group, and come on back when you're ready. Thank you very much. Look at the periodic table.